जी अस्सलाम वालेकुम class. My name is Engineer Hassanza and today we are going to start lecture about beams and their external effects and then their internal effects as well. So what is beam? Beams are structural members which offer resistance to bending due to applied load. Mostly beams are prismatic beams and the load usually applied normal to the axis of the bar. Bars are known as a beam. So beam are basically structural members uh, that offers resistance against the bending or stress or strains against the applied loads or against the forces and their produced movement. So beams are undoubtedly the most important of all structure members in terms of buildings, in terms of bridges, in terms of trusses. So it's important to understand the basic theory underlying the design. So we have a brief overview of beams internal effects and external effects as well. Okay, before going to this complete introduction, the first part of this lecture will be analysis requires the application of principle of statistics. Basically all the beams, all the external or internal parameters will follow the statistical determinant structures. If there are more forces or more supports than required, then the beam will be statistically indeterminate beam. So next one is the types of beams. Beams supported, so their external support reaction can be calculated by the method of statistics alone are called statistically determinate beam. If there are more supports than required, then this beam will be known as statistically indeterminate beam. And then there are different types of beams. Like first one is a simple beam with the one end is at pin joint and second one is at ruler support. And in case of continuous beam, one end is fixed at pin joint, then there are two or more ruler supports. Continuous means that there will be one end is at pin joint, second end will be at ruler support, and in between there will be more than one ruler supports. Cantilever beam fixed at one end and second end is open, and supported cantilever beam one end is fixed and second end is on ruler support. Combination one end is at pin joint and second end is open, and in between there is a ruler support. Fixed in terms of fixed beam, both ends are fixed. Then this diagram illustrates the load distribution in terms of beam. It can be constant, it can be varying in a regular pattern or in a irregular pattern. Then the distributed loads, uh, so we have to solve like this one. L is the complete length of the beam, and weight of the beam or a uniform load will be distributed likewise at the length of L by 2. R is equal to WL. W is the load and L is the length. So reaction will be equal to R is equal to WL, weight multiplied by length, and its point will be found by this formula, will be found by using this formula L by 2. And if the weight is increasing in a regular pattern, then R will be equal to 1 by 2 WL, and this point, action point, will be followed by 2L by 3, means 2/3 length of the total beam. And here is in this third case, W1 is equal to this point, weight is constant. Reaction will be followed by the using this formula. R1 will be equal to W1L, and action point will be L by 2. And for this varying triangular pattern, point will be 2L by 3, and R2 will be equal to 1 by 2 W2 minus W1 into L. फर्दर हम इसके न्यूमेरिकल देखेंगे तो मज़ीद ये क्लियर हो जाएगा. वेरी गुड एग्जांपल है. Sample problem 5.11. A continuous load of 120 pound per foot is acting on this beam, AB beam. Both ends are at pin joints, and at B point the varying load is as 280 pound per foot. For 4 feet the action or the load is constant, and for 6 feet distance the load is varying continuously, and the total length will be equal to 4 plus 6 is equal to 10. So we will solve the numerical as for 120 feet the load is constant on the 10 feet length, so total load will be equal to 120 multiplied by total length is equal to 10 feet 1200 pound, and its action will be total distance 10 divided by 2 is equal to 5, this 5. For varying load the formula will be equal to 1 by 2 W1 minus W2. W is equal to 280 minus 120, which is equal to 160, multiply by L. L for this is equal to 6 feet, which is equal to 480 pound, and its distance will be equal to, at the point will be equal to 2 by 3 into 6. So this one will be equal to 4. 4 plus this 4 is equal to 8, and the solution is we have to find the moment at point A. 1200 multiplied by 5 plus 480 multiplied by 8 minus reaction at this B point, RB into total distance is equal to 10. So reaction at B point 984 pound. Next we have to find the moment at B point. RA into total distance of this beam is equal to 10 minus 1200 into 5 minus 480 into 2. Reaction at A point is equal to 696 pound. So basically this is a perfect example of statistical determinant equilibrium based structure, and we have solved by using these formula as previously discussed. So this uh, example can be used, or the formulas has been used in example. L by 2 multiplied by W, R1 is equal to W into L, and for this varying load we have the formula to find the reaction. R2 equal to 1 by 2 W2 minus W1, 280 minus 120 into L is equal to 6, 2L by 3, 2 into 6 by 3 is equal to 3. By using this formula we have solved this miracle. Sample problem 5.12 you have to solve your own. Then you have to solve these first 10 numericals, and I have provided you solution. 5.93 को भी ये हम देख लेते हैं. So first of all its statement: determine the reaction at A and B for the beam subjected to uniform load distribution. Here we have a beam, fixed pin joint at A and a ruler support at B, and we have to find the reaction at A and reaction at B. Total length of the beam is equal to 600 millimeter. The solution is as force is equal to 6 kilonewton per meter, or the load 6 kilonewton per meter. It means if there is 0.3 meter distance, so R will be equal to 6 into multiplied by 0.3, and force will be equal to 1.8 kilo Newton, and its point of application will be total distance divided by 2, L by 2, 0.15 meter. We have to find the moment at A. According to equilibrium condition, movement should be equal to 0. RB multiplied by this distance, 0.6 minus 0.8 into this one distance. RB is equal to 0.45 meter. Summation of forces is equal to 0. Summation of forces will be as RA plus RB minus R. So R is equal to 0.45, RB is equal to 0.45 minus R is equal to 0.8 plus RA. RA will be equal to 1.35 kilonewton. So next 9 example are problems you have to solve your own. Thank you very much.